Welcome to the coffee lecture with the title 5S Data Organization is not a four-letter word. So maybe you already saw this coffee lecture in German a few years ago. This is now the updated English version. And we directly start with the origin of 5S Data. So the origin is actually from the concept of Kaizen, which was developed in the Toyota production system in Japan. And Kaizen means something like the act of making bad things better. So, or you can also rephrase it like learning from problems or from mistakes. And these five letters means Saeri, Saiton, Saiso, Saiketsu, and Shituke. So Japanese words, but surely in the West they are not so understandable like this. So they translated them in English to sort, set in order, shine, standardize, and sustain. And maybe when you are in Germany, you also find an equivalent with 5 A's. And here it's called Aussortieren, Aufräumen, Arbeitsplatz, Sauberkeit. Anordnung zur Regel machen, alle Punkte einhalten und verbessern, which, yeah, sounds really German. And these principles were not only used in Toyota, but also in other big companies like Boeing or HP. And in 2019, the University of Helsinki submitted a poster to the RDA, which references research data for this model. And we also addressed this topic, created this coffee lecture, and also created a comic, which I show you at the end of this coffee lecture. So now we can start with the first S letter, which stands for sort. And the goal here is in this step to make the search for the data more efficient and save data storage. And how do we do this? Simply by deleting unnecessary files and folders or mark them for the deletion later. And also another point is to keep the space maybe also free from temporary files. How do we do this? I have made a few screenshots here. The first one is maybe you already know how to delete files, but here again, I show you, you simply select files and folders and move them to the trash bin. That's the most simple way, but maybe right now you can't delete the files because they're occupied by some applications. So here other programs can help you, for example, like TextBases, Nextcloud, or Zotero, where you can put tags on files. And here you can, for example, put text on it like remove later. So you are remembered later that you have to delete them. And another workaround is to simply don't let a temporary file occur at all. So there are versioning systems like Git. And here in the git ignore file, you can state which files on your local system shouldn't be uploaded again on the server. So for example, if you use GitLab, and here you can see in this file, it's stated all the files that are generated in the binary, generated or output folder shouldn't be uploaded to the server. So all the files that you use, for example, you generate in experiments are only on your local system. The second step is, and I would say the biggest one is set in order. What does that step mean? The goal is to build a system to simplify your structures and workflows. And for this, we have to create a useful folder structure and have to create naming conventions and also should document the steps we take for this. So let's start with useful structures for folders. Here on the left side, you see a bad example for a folder structure. So here you can see they tried to numerate the folders, but not consequently in all folders. Sometimes they are written with big letters, small letters, spaces are sometimes exchanged with underscores, but not all the time. Or you see general folders at the bottom, like photos, so you don't know why they are here on the top level, or like sample lists or R, which stands for R script, I guess. So why they are here on the top level. So that's not a good folder organization. On the right side, you see a better example. So on the top, you have 4 folders for project management, empirical, so the study itself, for the paper or other disseminations, so things you make public. And when you see, for example, in the empirical, so the study folder, you see subfolders like input, so the input data, the code, scripts, one folder for the data analysis and the outputs in the end, so for example, for the diagrams. So general rules for creating a folder structure should be clear hierarchical structures representing the existing contents or the files and the processes, the workflow, and all the names should be short, easily comprehensible. And as a rule of thumb, it's good to follow that there should be only 3 folders in depth and at max 7 folders in width. Surely that's in most cases not possible, but if you could more or less follow these lines, that would be great. And then there's another problem with the names here, especially the names of files. Here also some bad examples. For example, you could use attributes at the end of a name like final, final2, final3. That's not a good way to name files. Maybe they are not named at all, like untitled, or they have generic names like photo, or there are numbers inside the name. You can't follow anything out of it, so you don't know what they mean. And that's bad for a human to read and to understand. But also maybe programs, applications have problems to read these files, especially when there are special signs in it, or they expect some specific naming. So for this, you should make naming conventions. And here's some rules you can follow. So on the technical side, there shouldn't be any special characters inside the naming of files and folders. So for example, the star can be a wildcard in many programming languages, and it is very dangerous to use it. And if spaces you can exchange for underscores or hyphens. You should also not use specific language-specific signs like umlauts in German. So maybe instead of Ö, use OE. It can be practical to not use uppercases. That's not so important, but for example, operation systems like Windows, they don't care if the letter is big or small. But if you use an other operation system like Unix, for them, they are different files. So it depends on the operation system how these files are handled. And the most important thing is also the naming of the file, the name itself can't be longer than 256 characters. That's not so short, but the problem is that also includes the path to the file. So, and if you imagine the file is on a server, also the whole path to this file is included here, and that can be over 150 characters or so, and then only 100 are left for the file itself. The other thing you should also consider is the content itself. So what is written inside the naming of the file. So there can be a timestamp, the author or the person who created the file, the category, so what is this file about, the title itself of the file, or also the versioning. But here, please use them sparingly. And here are 2 examples we use in our network for naming conventions. So we made a table with VFU, which is the short form for virtuelle Forschungsumgebung. And we created an overview here in a table, and it was the 4th version because we updated this file sometimes. And the other example is a paper with text. So we published it on the 4th November 2020. You see the timestamp at the beginning, starting with the year. So it's also sorted on our system. Then you see the author, our network, TKFDM. Then the category, it's a fact sheet. And then the short title, it was about open source software. Then we come to the next step, and this is Shine. And I guess many of you can't really guess what this means when you only hear the word, but it simply means to maintain the quality that we already created now with the first 2 steps and maybe adjust it if necessary. Also, we have to document it. And how do we do this? We simply check in intervals if all the workflows are working, and we should do this in regular routines. I don't have to show you much about this step, but simply look into your calendar and maybe take a day, so for example, Friday afternoon, where you check all the files, or maybe a week in a month. And things you can check, for example, is there any data junk on the desktop? Are the files all sorted? Are they correct named? And if you have not the time right now, maybe do it like with the text I showed you to create to-dos. But you also should consider can everything you created until so far be completed on time all the time? So maybe you created two specific naming conventions or folders, too many folders. It takes too much time to sort everything. So maybe you should go a step back and create a new ordering system. Now we come to the fourth step, standardize. It means that we have to go to establish processes and standards and enable it with collaboration so that also other people in our institution can use them. So we're not only working for ourselves, but also with our colleagues together. So we should document the best practices and guidelines rules so far. And the best way to use it on a higher level now is to implement a standard operation procedure, short SOP. And clarify with that the responsibilities and discuss them with our colleagues. So, but what is an SOP? You can imagine an SOP is like a DMP, so a data management plan, the topic of the last coffee lecture, but on a higher level. So while a DMP is only talking about the data management inside one project, the SOP is talking about all the projects. So everything that is done in an institution. And with that, we have the topics we already talked about, so like the standardized folder structures, naming conventions, but also other topics like, for example, permitted data formats, so which formats are allowed or which formats come from, for example, measuring equipment you have to use. Then what is the designated storage location? So where can you access the data? What backup and retrieval processes are there affordable? And then the next step is which user rights and responsibilities exists. So what can users do with the data there? How can they share or update them? And the most important part, the last point, is about the standards itself. So we are coming back to the fourth S, standardization. But maybe you ask yourself right now, okay, there are standards everywhere, but which one I have to use? And that's a really good question because standards there are many organizations who define standards. So for example, the NIST for security standards, I guess you know that the ISO, which is famous for the standardization, for example, for date formats or locations. Then there is schema.org, for example, for metadata standards on the web. And there is W3C for example, for defining HTTPS or FTP, so Internet Protocol standards. So, but which of these standards you have to use? And that's a problem. And not the problem on your side, but actually on everyone's side in research, because, for example, libraries or data standards all use their own standards. And this is a reason why some years ago, the NFDI, die Nationale Forschungsdateninfrastruktur, here in Germany was founded also with one of the goals to make a common standards in specific subjects. But sure, you can also use other platforms to find standards for yourself. And to name two at the beginning, there is the Research Data Alliance and the Digital Curation Center, some big communities which have directories with metadata standards. But there are also two websites which were created in the last years, bartok.org and fairsharing.org, which also have many metadata standards. The problem with these websites is that they have many metadata standards, but they are not controlled, so there is no quality check behind it, so everyone can upload metadata standards there. So one of the platforms which were created in the last 1 or 2 years is from the TIB, die Technische Informationsbibliothek in Hannover. And they not only collect metadata standards, they also check the quality of them. So are they widely used? Is there some base behind it? Then next, we have the last letter, sustain. This simply means that we want to maintain now the developed system by self-discipline and through habit by the researchers themselves. But how do we give them this opportunity? We have to automatize the steps to use, for example, the naming conventions or the folders, and we can also use templates for these. And you should do regularly workshops and training sessions also for onboarding new staff members, and maybe also evaluate new methods or technologies that exist. Here, only one slide for this. Yeah, you should do regular workshops to introduce the system or also the documentation of your institution. And with this, offer templates and explain your tools. So, for example, if your code is stored in projects like in GitLab, where are these projects? Where are the projects, for example, for the students, where you can find them? If you write text templates with LaTeX, where are these templates? How you can use them? What software do you need for this? Or for example, if you have experiments and you use ELAB FTW to protocol these experiments, how you use this software. And especially when you're onboarding new members, it can be interesting to ask them what software or methods they used in on their last previous work, because technology is changing all the time, and you should always ask around and inform yourself what are the new methods, maybe new software you can use, and should consider, and with that also updating the first steps of the S. And now I'm at the end of my uh, coffee lecture. But like I said, here's some other materials we have about 5S data. So we created a paper you see here on the left side with many informations about this topic. But also we created this comic with 5 comics and 3 panels each. And maybe also this comic can help you to understand what the 5S data principles mean. This is the end of the coffee lecture. Thank you for your attention.